Hi everyone, my name is Mr. H. For those of you that don't know me, I teach two sections of the High Honors Geometry class, and today I'm going to take you guys through a problem on angles of elevation and depression, specifically on a problem where you would need to use two angles of elevation or depression. So this is similar to problem 3, or example 3 from your notes last week. And we feel the need for you to see another one just because sometimes they're a little bit more involved and they have a lot of steps. So it's good to see a couple examples. And also this particular problem that we're going to do incorporates a lot of different things that we thought would be beneficial for you to review. So the problem specifically that I'm going to be doing is number 9 in your book on page 584. So number 9, it's a diving problem. It says Austin is standing on the top of a high dive at a local pool. 2 of his friends are in the water on the opposite side of the pool. If the angle of depression to one of his friends is 40 degrees and 30 degrees to his other friend, who is 5 feet away from beyond the first, how tall is the platform? So let's start with making a drawing, because in order for you to succeed with any of these problems relating to angles of elevation and depression, you really need a good drawing. So we know we have Austin on a diving platform. Ultimately, it does say how tall is the platform, so we do not know that information yet, so I'm just going to leave that blank. It then says in the problem, 2 of his friends are in the water on the opposite side of the pool. So if here's Austin over here, and here's our pool, we have 2 friends. One's here, and here's another one over here. Now, it gives us some information. So it says, the angle of depression to one friend is 40 degrees, and the other is 30 degrees. So now we have to figure out which angle goes to which swimmer. So again, we're dealing with angles of depression right now, so we are looking below the line of sight. So I just drew a dotted line from where Austin would be seeing up here. So now we are looking down first at this friend. So from there, did that in green, so hopefully you can see that. And we are also looking from this one over here. That one's going to be in purple, so it'll be a different color. Now, we have to ask ourselves, well, which of these angles is the 30 degree and which one is the 40 degree? So obviously we have 2 angles right here. We have this angle, the purple angle. And then we have the green angle. The green angle is bigger, so that will be our 40 degree angle. And this one will be our 30 degree angle. Before we go on and do any more work, we need to make sure there's no other information it says. And then it also informs us that the friend is 5 feet beyond the first. So this right here, this has to be 5 feet. 5 feet. Okay, so that's everything that it gives us in the book for information. However, if you are looking at the book and you're following along right now, you'll probably notice that the drawing in the book is different from what I just drew up here. The reason behind that, they gave us angles of depression. The book itself does not appear to be giving you angles of depression. Their drawing is right. There's nothing wrong with their drawing. But the way they drew it was not necessarily with the angle of depression. So what they did was they said, okay, this up here is 40 degrees. And this line, the line of sight of Austin, is parallel to the pool itself. Because this is parallel to this, the line of sight is parallel to the pool. We know that these two angles, this 40 and this one right here, they are alternate interior angles. Because they are alternate interior angles, they are congruent. So this one must be 40 degrees. Similarly, we know from the same reasoning that this angle up here, which was 30, over here is also 30. And that's where they got the drawing in the book. So that's why, even though it is explicitly saying angle of depression, and you're looking in your book and going, okay, well, how come if they're giving me angle of depression, it doesn't look like an angle of depression? They kind of just cut out the middle step. So that's how they got to this drawing. Now, before we can do anything, we need to make sure we are clear on what we are solving. So it is ultimately looking for how tall is the platform. So this is my first thing that I do not know. I do not know how tall that platform is. Unfortunately, at this moment in time, we do not have the necessary information to directly figure that out. In order for us to use trig, we would need to know a side length. The only information that we have at this point is that this right here is 5. We would need to know this component as well. And that is really where a lot of the difficulty of this problem comes in, because this is a little bit of a lengthy calculation. So we don't know what that is. I'm just going to call it y. So that is what we need to find to be able to find the actual height that we are looking for. So let's start with setting up the trig ratios that we can solve these. We have here a 40-degree angle. We are looking for the height. And we also have the other side, the adjacent side to it. So we have the opposite side and we have the adjacent side. We don't actually know what they are, but that is specifically what we are dealing with in this problem. And just for clarity, I'm gonna make sure we are aware that is a right triangle. So we again have an angle, opposite and adjacent. So when we have opposite and adjacent, we are going to need to use the tangent. So let me do it in the right color. So we have tangent of 40 degrees is equal to opposite over adjacent. So as a reminder, let me just put that over here. Tangent, our angle, is opposite over adjacent. So just so we remember that. Okay, so we now have the tangent of 40 degrees is x over y. Now we have the purple triangle over here. We are going to use that information to set up another equation. So again, we have an angle, the opposite side. We still don't know anything about the hypotenuse, so we're not going to use the hypotenuse. And that only leaves, again, tangent. So we have to use the opposite and the adjacent. However, the adjacent's not 5, and it's not y. It's both. It's the whole bottom part of this pool. So it is 5 plus y, or y plus 5. So when we set that up, we get tangent 30 degrees is equal to, again, the opposite over the adjacent. All right, now you're probably looking at that and going, well, that's lovely and helpful, but that doesn't do anything for me. Still don't know anything about these ratios. I can tell you that they're not the same. That's all we know. Because we know that this is some number, and it's equal to x divided by y. And we know that tangent of 30 is some other number, and it is equal to x divided by y plus 5. We actually can figure out what tangent of 30 is really quickly using special right triangles, and we can figure out what tangent of 40 is if we were to plug into our calculator. But the problem is that still doesn't directly tell me how to solve for x and y. And if we were to do those calculations now for what tangent of 40 is and what tangent of 30 is, and we were to write them down, we might end up a little off in our answer because of a rounding error. So we are going to leave things in terms of tangent of 30 and in terms of tangent of 40 for now. But let's look back at the problem. So ultimately, the problem itself is saying, how tall is the platform? And we are saying the height of the platform is x. I don't know what x is, but I'm still trying to find it. So let's just solve both of these equations for x. Over here, again, we have x over y is equal to tangent of 40 degrees. Tangent of 40 degrees is some number. I do not know what number it is off the top of my head, but it is some number. So we can multiply both sides by the y. So that way it cancels out on the right-hand side of the equation and we leave it on the left-hand side. So I'm going to multiply both sides by y. And I am left with y times the tangent of 40 degrees equals x. Again, I want you guys to remember, tangent of 40 degrees is some sort of number. We can find it. We can plug it right into our calculator. We could get something. In fact, if I were to plug it in right now, tangent of 40, it ends up being, tangent of 40 is 0.83. 0.84. So it's just some number. I'm not going to put it as that yet, but just remember, it is a number, so this is okay. This is something that we can work with. It is nothing that we need to be afraid of. This is not some variable. It is a number. Okay, so we have x is equal to y times tangent of 40 degrees, or x is equal to y times a number. Now let's look over here. As opposed to multiplying by y this time, we have to multiply by the denominator of y plus 5. So we'll multiply times y plus 5 times y plus 5. Cancel. Okay. So now, again, we have x just left on this side. We have y plus 5 times tangent of 30 degrees. Again, tangent of 30 degrees is a number. We're multiplying a number times y plus 5. That's what x is equal to. So we now have two equations that tell us what x is equal to. And we know x is a constant. You know, if we look at the height of a diving board, that does not change. So therefore, we can say that these two values must be equal. Y times the tangent of 40 degrees must be equal to y plus 5 times the tangent of 30 degrees. So we'll set them equal to each other. Okay, so it's just like solving any other system of equations. We have two things that both are equal to x, so we're just setting them equal to each other. Just like what you would have been practicing last week in one of the Delta math assignments with the systems of equations. That's all we're doing. Again, I don't want you to get confused by the fact that we have something like tangent of 40 degrees or tangent of 30 degrees. These are numbers. Essentially, they would be the coefficients that you're dealing with. There's nothing to be too concerned about. It doesn't look like a number that you're used to, but it still is a number. Okay, so when we are in a scenario like this, we need to get all the variables onto one side. And in order for us to do that, we need to get this y out of the parentheses. Again, this is just some number times something in parentheses. So we can distribute it. So ultimately, when we do that, we get y. We'll put that in green. Keep y times the tangent of 40 degrees. When we distribute the tangent of 30 degrees, we're going to get it equal to y times the tangent of 30 degrees plus 5 times the tangent of 30 degrees. Okay, so all we did was we just distributed tangent of 30, some number, to the y and to the 5. So we're almost there. We're almost at the point where we have all the y's on one side. So now we just need to subtract this term, the y times tangent of 30 degrees. Subtract that from both sides. And we end up with y times the tangent of 40 degrees minus y times the tangent of 30 degrees is equal to 5 times the tangent 30 degrees. Now, again, you're probably wondering, why am I not bothering to replace tangent of 40 degrees or tangent of 30 degrees with something like the 0.84 that I had said earlier. So if we do that now, we are going to end up with a rounding error, and we are trying to avoid that for as long as possible. So now we need to get the y's out, or separate them from their coefficients. So both of these terms have a y in common. Since they both have a y in common, the two terms have a GCF of y. So we can factor the y out. I'm going to switch over to just using the black pen because it's a little bit harder to see now where all the terms directly are coming from. So we have y times, when we separate the y, when we factor out the y, we're just left with the tangent of 40 degrees. And when we factor out the y from here, we're just left with a negative tangent 30 degrees. That's still equal to 5 times the tangent of 30 degrees. Okay, so we now are almost at the point where we have y by itself. Again, tangent of 40 degrees is a number. Tangent of 30 degrees is a number. A number minus a number is still a number. So because it is just a number, we can divide by it. The only time we could not divide if we knew it was 0. We know up here that clearly the distance is not 0, right? Because otherwise we would have somebody at a 90-degree angle of depression. So therefore, we know they're not 0. Okay, so we can divide by this number. Tangent of 40 degrees minus tangent of 30 degrees. Divided by tangent of 40 degrees minus tangent of 30 degrees. Okay, so when we do that, this part will cancel. Tangent of 40 degrees minus tangent of 30 degrees divided by tangent of 40 degrees minus tangent of 30 degrees. It's some number divided by the same number. Any number divided by itself is just 1. So we're left just with y is equal to 5 times the tangent of 30 degrees divided by the tangent of 40 degrees minus the tangent of 30 degrees. All right, so now we have what y is. This is a number divided by a number, so it's some number. At this point, it's kind of hard to plug that in somewhere. So I would recommend you put it over here. I am going to erase some of this middle work right now just because of the difficulty for me to try and plug it in. So I'm left with that. And y is equal to tangent of 30 degrees 5 times the tangent of 30 degrees divided by tangent of 40 degrees minus tangent of 30 degrees. Okay, so we know that's what y is. Now, earlier, when we were trying to solve for that particular problem, again, we're trying to solve for x, whatever the height is, we came up with an equation where we had that tangent of 40 degrees was equal to x over y. When we multiplied both sides by y, we got x was equal to y times the tangent of 40 degrees. I now know what y is. It's this number. I don't know what this number is yet, but it's this number. So let's plug it in. Again, we're just substituting in for the y. So we're going to take this right here. We're going to plug it in right for that y. So we have that y, which is now 5 times the tangent of 30 degrees divided by tangent of 40 degrees minus tangent of 30 degrees times the tangent of 40 degrees, and that's what x is. So again, this is some number. This is the height of my platform. It is really not beneficial for me to leave it in this form at this point, just because if you look at this, I don't actually directly know what this is. Let me just clean it up a little bit before I plug it into a calculator. So whenever we're multiplying a fraction times the number, we can just put the number in the numerator. So we're getting 5 tangent of 30 degrees times tangent of 40 degrees. We are dividing that by tangent of 40 degrees times the, minus the tangent of 30 degrees. And again, that's what x is. Now, unfortunately, there's no simplification I really can do at this point to cancel anything out before I plug it into my calculator. The only other thing we could do was I could tell you off the top of my head that tangent of 30 degrees is equal to root 3 over 3. Unfortunately, that really doesn't provide any additional insight. In case you're curious why that's true, it is true because if you have a 30, 60, 90, 30, 60, 90, our ratio had that as 1. This was 2, the hypotenuse was 2, and that was cube root of 3, sorry, the square root of 3 across from the 60. So if we then did the tangent of 30 degrees, it would be opposite, which is 1, over the adjacent, which is square root of 3. So we have tan of 30 equals 1 over the square root of 3. Now I don't leave things like that. I need to rationalize times the square root of 3 times the square root of 3. And that's where I get my tangent of 30 is a root of 3 over 3. And that's why it is that way. Unfortunately, I don't really think it provides any additional information at this point in our problem. So what we are going to do is we're just going to now put this number into our calculator. We just need to make sure that we are in degree mode. If we're not in degree mode, we're going to get a drastically different answer. So we do need to make sure we are in degree mode. So when we plug it in, we get 5 times the tangent of 30 times the tangent of 40. We're going to divide that by, in parentheses, make sure you put this part in parentheses, because otherwise it's not going to come out right. Because it'll just do tangent, 5 times the tangent of 30 times the tangent of 40 divided by tangent of 40, and then subtract the tangent of 30 if we don't put it in parentheses. Be careful as well with the parentheses around your 30 and around your 40. If you're not careful with those, you might end up with subtracting the tangent from the actual angle as opposed to having them as two separate terms. All right, and so ultimately I get my answer as being x is equal to 9.254 in my units. I believe were feet, was feet. So we can say, after all is said and done, that the height of this diving platform was 9.254 feet. And let's double check and make sure that we did everything right. So again, the odd number problems are in the back of the book. You can check your work on those. And when we do it all out, it says, well, rounded to the 10th, but I prefer to be a little bit more exact. It said approximately 9.3 feet. So we are good on that. Please let us know if you have any questions and if there's any other information that you need to be able to succeed with this. I hope this was helpful and clear and provided you with some information that you might have forgotten in the past, or provided some clarification for some of the problems that you looked at last week. All right, thank you.